Welcome back to the shop and to the channel. Well, today I've got a project that I want to get started on, something I've been thinking about for a little while, and I think it'll become useful for many projects to come. I often use these telescoping snap gauges when I want to measure the bore of some object that I'm working on. Once I have that gauge set to the bore, I use a micrometer in my other hand to measure the gauge to determine what the ID of the bore is. This is a pretty easy thing to do. It's not all that difficult. But when I'm using larger micrometers, that can be a real challenge to balance the big ones in my hand. And I think it would be useful if I had some way to hold the micrometer steady in a holder or a stand, and then I can use one hand on the thimble and then the other hand to use the gauge. And I know you all know what I'm talking about, at least I presume you do, and that's something along the lines of this micrometer stand that I saw recently on Kyle Vanover's YouTube channel, Vanover Customs. He was talking about these new micrometers that he purchased and was showing them in a micrometer stand that he received as a gift. And I thought about going out and just buying one, either one like this. I know Starrett makes one, and then you can get a whole bunch of different brands from import companies that look like they're okay, but they also look kind of cheap. So I think what I'd rather do is make one. And so I started looking around for examples of what other YouTubers may have made, or even stuff on blogs and the different forums of what other machinists might have constructed in their own shop, but none of them really kind of spoke to me. They all had some good points, but I wanted to try to find something that put all of those good points together and then kind of added my own personal touches to it as well. So after spending a couple hours in Fusion 360, this is what I came up with. And the idea is that it will have a heavy base and a riser, a adjustable swivel ball joint, and then the clamping mechanism will be on top of that. And you can probably see from this cutaway that it's made from quite a few different parts. I've overcomplicated this thing for sure, but that kind of seems to be a little bit of what I do. So there's about a dozen parts that make up this micrometer stand. Well, what I like about Fusion 360 is I can do this 3D design and modeling, and then I can easily create design plans from them. So I'll print out a few of the first parts, and we can head into the shop and get started. I'm going to start here with the base, and at first glance this seems to be a pretty simple part. It's got an X and Y dimension here, although I forgot to put on the length. It's got a hole that's drilled into the center of it, and it's got these different facets in it that just kind of give it an interesting look. For stock, I'm going to use this piece of tooling that came home with me from an auction lot. It had a bunch of other stuff in it, including these fixtures. I have no idea what these things were originally used for, although they're stamped with Hasserot machine tool from right here in Cleveland, Ohio. They're still in business. They're like a tool and die company, so it must have something to do with tool and die work, but I don't know for sure. So if you know what these things might be used for, leave a comment. I do want to get over to the bandsaw and trim off these ears though first. Well, it was pretty easy work on the bandsaw. It went right through it just fine. I also checked these with a file, and the file cuts it just fine. I'm sure this is made out of some kind of tool steel, but it seems to be fairly machinable, at least up to this point. My dimensions on the drawing are going to probably change a little bit once I get this cleaned up, and I think I want to use the shaper to do that. Well, I got this set up in the shaper here to try to clean up this top surface. I am using some anchor lube here as a lubricant, cutting fluid. I've really begun to appreciate this more and more as a cutting fluid, not just for drilling and tapping, because it doesn't smoke, it doesn't stink, and I think it does a really good job of keeping the tool and the part cool. Well, the surface finish is not as good as I would like it. It started off pretty good, but then as it got toward the opposite end, it started getting really rough. And I think maybe that had something to do with the rust, possibly. I'm not really sure, but I'm going to take this tool out and give it a hone, sharpen it, and then I'm going to try to take another pass. I still have 50 thousandths or so to come off on the thickness, so I have a little bit of room here on this side before I turn it over to start machining that side. So with the tool now freshly sharpened and honed, I'll take maybe another 20 thousandths off of this surface. Well, unfortunately, once again, the surface finish is terrible. It not just that it looks bad, but you can feel the roughness, the texture in the surface, and that's just unacceptable. So maybe this material is a little harder than what I thought, or I didn't get a good grind or hone on the tool bit. I'm probably going to have to regrind it, unfortunately. It's got a really good profile, and I really didn't want to have to do that. But I'm laying bets on this as just being harder than I expected. So I think what I'm going to do is unfortunately abandon the use of the shaper and take this over to the milling machine and use a face mill. So we got it in the mill here. Again, a little bit more anchor lube on the surface. I'll probably take maybe 15 thousandths off here. I don't want to go too far below my target of 1 inch. If I go below that, it's not a big deal. I can just adjust the drawing. But I think we'll try 15 thousandths and see how it does. Well, I will say it's interesting that as it traversed to the opposite end, that it didn't actually cut anything. I didn't think that this piece was that much out of square. At least it wasn't when I was trying to mill this on the shaper. And it looks like here when I try to mill the second half, again, the face mill's not even touching the part. Something is not right. Well, I rotated the inserts around and put a fresh corner on all of them. I probably should have done that to begin with, and we'll see if this is going to do any better. Yeah, this surface finish it's just not good. Not good at all. Well, that last pass made it better. It's still not perfect. I think I'm going to just keep going with it and see where it takes me. Now this side here came out great. You can see some machining marks in it, but you can't feel them. So I don't know. Maybe that front surface is just a little bit harder, or maybe it was just a hardness layer. Let's keep going. Yeah, it's definitely harder on the faces. There's got to be some, what do you call it, case hardening on this piece that I'm trying to mill through. I think that's what all the sparks are coming from. The chip color is interesting. It's a very copper colored chip when it cools down. It's not, the blue or, sort of that tan color you would expect to see. It's a copper color. So I don't know if that's a good indication of what kind of tool steel this is made out of. I'll have to do some research and see if I can figure out if that might tell me or give me a clue as to what material, what alloy these things were made from. Well, I'm finished milling it to its overall dimension here. I didn't get the target dimensions I was expecting, but that's okay. I can always redo the drawing. But the surface finish it's just not acceptable. And I think I'm going to have a lot of problems when I go to do the other machining, trying to machine those facets on the top. So what I think I'm going to do is scrap that part. I really wasn't happy with the surface finish, and I felt like I was going to be fighting it and fighting it and fighting it. So I've got this other piece of stock that I think I can go ahead and get a nice chunk out of. It's going to be a little bit bigger than my original drawing, but that's okay. I can always adjust the drawing to the size of the material. So I just need to take it over now to the bandsaw. We'll go ahead and cut off a chunk of it, and I guess we're starting over. Well, here I got it fresh off the bandsaw. Say what you want about these Harbor Freight bandsaws, but I'm telling you, it cuts a pretty square cut. Spend a little bit of time with them, and you can dial them in and turn it into a really great tool. This base is going to be a lot bigger than my original drawing, but like I said, I can just go back into the CAD drawing, change the dimensions, and then everything else adjusts. So I think we're going to go ahead and take this back over to the shaper and see if we can't get this cleaned up and square. Well, once again, a less than ideal surface finish. I think the tool bit that I have in here is just dull. I'm going to have to sharpen it. I don't think it's the material, but I think it could be. So I think what I'm going to do, I've got another tool that I know is sharp, and it's more of a finishing tool. It's got a rounder cutting edge on it, so I'm going to put that in the shaper and give that one a try. Well, I just can't catch a break with the shaper. I know those tools are sharp. At least they certainly feel sharp on my thumbnail, but I am just getting horrible surface finish on the majority of it. On the one end, it seems fine, but then on the far end here, it seems to getting rougher. I'm not exactly sure how to explain how this feels. It might be difficult to see it, but rest assured, it's unsatisfactory. I can't, in good conscience, continue with this. So it's back over to the Bridgeport, and this time I think I'm going to use the fly cutter. Uh, I've had really good success with it, but then again, I've had really good success with these other tools. So maybe this just isn't my day. Now that's the finish I've been looking for this whole time. It is perfect for what I want. So I think we're going to go ahead and rotate this and finish this part out using the fly cutter. Now that is a massive improvement on surface finish than this first piece. I don't know what that was, but it's probably going to go in the scrap barrel, and I'm just going to scrap it. Or I might stick it back on the shelf because I'm a glutton for punishment. So I've got this down to a size, and what I think I'm going to do now is go back in and update the CAD drawing to reflect this new size, and then let all the dimensions be recalculated to fit this piece. Well, I have new calculations on the drawing, and I put some Dicom on it with some anti-bozo lines on here, so as I machine these different facets, it will let me know if I'm getting close to screwing up. But the first thing I need to do is I want to bore the hole that is going to be used to mount the riser. Well, I know I'm breaking some kind of cardinal rule here by putting an end mill in a drill chuck, but I'm just using this for the counter bore for the socket head cap screw that will be used to mount the riser to the base. So I'm not going to be side milling with this. I'm just going to be boring this down maybe 300 thousandths of an inch. Well, with the main machining done and the hole drilled for the mounting bolt, I can now concentrate on machining these facets. Now I need to figure out how to set these up in the mill so I can machine off the surfaces at these rather precise angles. Well, to figure out what those angles are, I let the CAD software do it. I put all the dimensions in I want, and then I let it calculate, for example, this angle here being 26.901 degrees. I know I'm never going to get that close, but we'll see how close we can get. And how I get that angle is I'm going to use a little trigonometry and this 2.5 inch sine bar. Well, the sine bar along with a set of precision gauge blocks. Well, these were precision at one time, I'm sure, but they're good enough for the stuff that I do in my shop. I'm not using them for inspection. I'm using them mostly for setup. Well, using a little trigonometry, I know that in order to get a 26.901 degree angle with a 2.5 inch run, I need a rise of 1.1311 inches. Now it's just a matter of stacking up gauge blocks in order to get a height that's equal to 1.1311. Well, I have my stack of gauge blocks here, and just to do a little bit of a sanity check, we'll bring a micrometer over here and check to see if I am in fact getting 1.1311. And it might be off by a half a thousandths or so. These gauge blocks aren't great, and that looks like it's off a little bit, but again, close enough for what I need these for. So in theory, if I set these up underneath one end of the sine bar, that should set the angle of this sine bar relative to the base to 26.901 degrees. Well, I've got a parallel flat on the base of the vise here, and I can now put my gauge block stack and my sine bar on top of that. That should give me some assurance that that is flat. And then I can go ahead and put my stock in the vise and clamp it down. Well, I'm sure there's much better ways to hold this part in the vise than using gauge blocks and a sine bar. Maybe there are, but I'm doing what I know and I'm working with what I have. Well, I'm not super happy with the finish on this, so I think I'm going to swap this end mill out for something else. Well, I just have a simple 2-flute end mill in here now, and we'll try to take another 100,000 step to cut. Well, I decided to take the other pass on this the opposite direction, which is essentially a climb cut, and this was a mistake. It's really hard to see on camera, and you really don't notice it until you start looking at the overlap line or even where the cut finishes. But the climb cut was actually pulling the part up out of the vise at that angle. So where the sign bar is touching that stack of gauge blocks, well, right here it's not touching anymore. It's actually pivoted it up, and it's now away from where it was originally held, and I ended up taking a deeper cut than what I intended.
Something happened there.
Yeah, those gauge blocks are no longer touching the sign bar, and actually pulled up a good 60 thousandths. Now my flawed thinking here was that I'll just take lighter passes and I won't have this problem. Of course, that is also a mistake. I was able to get away with this. I was thinking that, I would rather save the time in machining, but, that's some flawed thinking. So after this last climb cut here, I decided to go back and just do pure conventional milling. And that way the forces on the workpiece are to the right and down, and that'll keep that sign bar pressed against those gauge blocks. Well, to machine the rest of these angles, I decided to switch over to this 2-inch face mill I have, this index face mill. I really don't like this tool. It gives me a little bit more chatter in the finish than I would like. But again, for this part, I think I can get away with it, and I think I'll clean this up on the Scotch-Brite wheel anyway to try to smooth out the finishes. But I want to take 100,000 depth of cuts and try to do this in single passes rather than multiple passes per depth of cut. Well, this is probably the most jacked up work holding setup that I could have probably come up with here. I really couldn't come up with anything else that would hold this piece at the angle that I wanted easily with the tools that I have. So this is what I have. A sign vise would be nice, or even a machinist vise that I could set up in here would be nice, but I don't have anything that would fit in here. So this is what I have. I'm just going to have to be careful with it and probably take lighter cuts, but I think we can make this work. I just have to be careful. Well, that can't be good. Okay, so back to the drawing board here. See if I can't figure out how to keep these gauge blocks in position. Well, we'll see how this works. I've got a big setup block that I use a lot, clamped to the base of the vise with a toe clamp, and really it's just there to hold those gauge blocks in position. So if they do rattle, they don't have anywhere to go. Well, this is my last setup here to machine these facets, and this one here is a little bit better than the previous one. There's a lot more of the stock still in the vise. I'm still got that setup block toe clamp to the vise to keep the gauge blocks from migrating, but this should be a little bit more stable. Well, here's my finished part. I spent a little bit of time with the Scotch-Brite wheel on the buffer, and that cleaned up most of the machining marks. There's still some left in on that large facet, and it's a little disappointing. I need a better face mill than that. That right there I bought off of somebody on Practical Machinists, and it was pretty worn, and I got it cheap, and I knew it was not going to be the greatest, but it has been working for me up until now. Maybe part of that is this material. I still don't know what it's made from. Well, I will say it was fun to use the sine bar for the first time and the gauge blocks to set a precise angle. It's a pretty interesting what you can do with tools that seem a little simple as long as they're made right. And to get these angles and get all these facets to line up was really cool to see it kind of come together. Well, the next part I want to make is this riser. This will get bolted to the base with a threaded hole down the middle, and there'll be this 3/4 24 threaded part on the end for the clamp nut. Well, but I think I'm going to do that in another video. This piece here, even though it seems simple looking at it, it actually presented a lot more challenges to me than I was expecting. Well, if you like the video, give it a thumbs up. Subscribe if you're not a subscriber, and don't forget that bell icon. And a special thank you to all the folks out there that have donated to the channel through PayPal or Patreon or other means. Well, thanks for watching, and we'll see you on the next one.